Yeah, there you go. I was going to say we are going to record today because we did start a website for our chapter, which I think Gianna's going to put in the chat box. So if you did miss today, or if you wanted to listen to it again, a recording of it will be on the AAZK website. So without further ado, let's just get started. Lauren, I will kick it over to you.
Okay, technology is not my strong suit. Oops, I just made my presentation big, but then I lost Zoom. I think I have to share first. Where's my little share? There it is. Okay. Boom. Do you see that?
Yep.
Yes.
And then if I do this, does it make it full screen? Oh my gosh.
Yep.
Yeah.
Okay. Again, I'm going to start off by apologizing because I've been extremely busy this week and I am very far behind on this presentation. So if anyone wants more information about full spectrum lighting or how it applies to their animals or our specific animals here at the zoo, please reach out to me. It is becoming a more like an increasingly studied topic with lots of new information, particularly around providing it artificially in a zoo and aquarium environment. And so things are changing rapidly in a very good way. We are learning so much more, not just about full spectrum lighting, but how to test and accurately read it and how that impacts our animals. So first, I want to just say that it is critically important for our animals, all life on Earth. And it is the foundation of good animal care. And of course, I'm going to have a reptile and amphibian focus here because that's what I use full spectrum lighting for. But I'm trying to focus on all taxa here. But again, sorry that it's going to be very reptile focused, but know that this is important for all life on Earth. So all of our taxa are impacted by full spectrum lighting. So what exactly am I talking about when I'm talking about full spectrum lighting? I'm talking about this major free resource that all life on Earth has, which is daylight or sunlight. And depending on your taxa, the exposure is going to vary. So the things that we're going to consider when we're thinking about what level or spectrum lighting we want to provide our animals are their natural history. So are they diurnal, nocturnal, or crepuscular? And all three of these categories are impacted by sun. And like, for example, nocturnal animals, while they aren't out during the day, during typical daylight, they are impacted by the infrared heat that the sun provides to the Earth. So think of it in that manner. And then their behavior. So even if they are diurnal, are they basking in the sun? Are they hanging out in the shade? What is their behavior during the day that will dictate their direct exposure to different levels of the different spectrums? And then their biological needs. So there are studies on captive animals that show that animals, for example, with high calcium, high vitamin D diets will not seek out UVB light as readily as the same genus, the same species that does not have that in their diet. And so their diet, this isn't in a vacuum. Full spectrum lighting intersects with all other types of our aspects of care, such as humidity, hydration, and diet. So these things are not in a vacuum. They are all interrelated in the wild. And so we need to consider them as such in the zoological field. And so I just put a couple of the biological needs on here that are forefront for reptiles and amphibians, which are obviously being ectotherms. Their metabolism and their immune systems are highly dependent upon heat and temperature, but also UV light and vitamin D synthesis, which is just critical for bone development, reproduction, things like that. And then thinking about their communication channels. One of the very first things that I learned as a herp keeper was trying to evaluate an animal from the animal's perspective. And in order to do that, we need to know their communication channels and how they interpret the world. And so it's very different, obviously, for reptiles and amphibians as it is for humans, but same thing with, all other taxa. I mean, obviously, the closer they're relatedness to us is, the closer their communication channels might overlap. But it's important to remember that communication channels are critical for how they are seeing the world. And that's so important for us to take into consideration. And then just that it feels good, right? Like I'm an animal, I'm a living being. I love laying out in the sun. It does feel good. It obviously also impacts all of those things for me too. My vision, vitamin D synthesis, how many people are on vitamin D supplementation these days? And we can get that for free from the sun. But then we have to also remember that the sun can have some negative consequences. So basically, we're going to split full spectrum lighting into 3 major categories. That is UV, UVA and B, then visible light, and then infrared. And so you can see in my kind of diagram to the right here, we do that by wavelength. And you can see the different wavelengths that make up those different categories of full spectrum lighting or sunlight. And then infrared is broken into infrared A, B, and C as well. So there's UV, A, B, and C, and infrared A, B, and C. But then it's important to remember in terms of being on Earth that the atmosphere does block out certain wavelengths. And so what that blocks out is basically all of the UVC. So something that we don't have to consider for our taxa is UVC, as well as the short wavelength UVB. And I also apologize, I still have a cough for like months. So excuse me. I'm sorry, I also recognize that I talk really fast. Hoping that being back in the Northeast, you guys are used to that, but if I need to slow down, just like throw me a wave or something, okay? So here is that solar spectrum, right? We're focusing right here on the visible ranges, which we'll talk about in a little bit more detail, but I wanted to kind of highlight the visible light spectrum as well as the UV spectrum as 2 things that I think I usually highlight this because in herpetoculture, we have a very big focus on temperature. So IR, we have been, and for a very long time, recognize that reptiles bask and are ectothermic and need temperature gradients. It is newer to consider UV light, and it is even newer to consider visible light in our field. So here are basically the spectrums that are coming through our atmosphere that we want to consider, right? So those UV A and B, the visible light, and then the really important short wavelength infrared IRAs that we're using for warmth. And so what that looks like to an animal, and the way we're going to go through this presentation, because I want us to, this is like a really complex topic that I tried, so you can tell me if I succeeded or failed, to simplify towards here's what we want for our animals, and here's how we can go about getting that. So that's kind of why I tried to focus on the benefits of these spectrums and go from that into the details. So we're going to look at it in 4 different ways. The solar energy, which is providing warmth to our animals, then light and UV, so that we use for vision, and then light intensity, which dictates kind of activity levels. And you can think of their like circadian rhythms, their seasonality, their daylight cycles in that category. And then highlighting UVB, because that has been really focused on in herpetoculture specifically, but I think also for mammals and birds very strongly in terms of calcium metabolism and vitamin D synthesis. So we'll look at vitamin B as well. I mean UVB as well. Okay, so starting out with solar energy, we're going to get most of our solar energy from the UVA, the visible light, and then of course our infrared short wavelength spectrum. And solar energy is made up mainly of visual light and IRA. Very little IRB, and then like I said, the IRC is not penetrating through the atmosphere. So these red wavelengths, these red spectrums are what penetrate the body best. So these are really, really important in terms of cell growth, wound healing, the animal's immune system. So you can see on my diagram to the right kind of how these spectrums are impacting our animals and the benefits that they provide. It penetrates the skin the best, IRA. So a lot of people historically have given IRC to reptiles. So IRC is kind of that IRA that bounces off the surface almost or absorbs in, and then it re-radiance is back out as IRC. So it's not the IRC coming through the atmosphere, but it's the surface. It's the absorption of the temperature off of the surface. So we utilize that a lot with reptiles in the past through heat mats. So a heat mat for like a tortoise or a lizard, and sitting on that heat, that would represent kind of the IRA turning into IRC warming of the animal. And it just doesn't absorb into the body and through the skin like IRA penetrates the skin. So IRA is much preferable to IRC. But it is also an important part because, as you know, all animals that bask, they're sitting on a warm surface as well as exposing themselves. So they're being heated from the bottom and the top. And so that is an important component of how their bodies are absorbing heat and using it for their metabolisms. So how can we measure IR in zoos? So typically and historically, we have used temp guns, right? So everyone has temp guns. I mean, now that COVID came out, I think every home probably has a temp gun in their house. So it's important to remember that a temp gun works from distance and puts out an angle. So the closer you are, the more accurate your reading is going to be. And what you don't want to do, and we're going to talk about it a little bit later in here, is be far away, because you're going to convolute your reading and get air temperature instead of the surface temperature that you're looking for. So this is giving you a surface temperature based on the IR readmittance coming off of that animal or surface that you are reading the temperature from. And then something that I just recently purchased before I moved here that I want to start using is called a power meter. A power meter has a spectral range of 1,000 to 1,700 nanometers and can read IR. So that's what I want to look at when I'm looking at evaluating our light bulbs or our heat sources in our reptile house. I want to not just look at the surface temperature I'm providing, but I want to look at the IR spectrum that I'm actually giving those animals so that I can evaluate different heat sources and bulb types for the best and highest quality spectrum lighting that I can find. So those are the ways that we can evaluate the IR in our exhibits and that we're giving our animals. And then remembering how we're going to get it. So what we want are those short wavelengths, like I said. And so the two best ways to do that are these patio heaters and these halogen light bulbs. And so several of these have been tested, but this is the goal to get the best possible heat to our animals. Patio heaters and halogen light bulbs are currently like what is recommended. What do we want to move away from? We want to move away from these longer wavelength heaters, such as ceramic heat emitters, which are highly popular in the reptile field, heat pads that only provide IRC. And one thing we want to be very careful about is overheating. So it can't be stated enough that all these components of sunlight are really beneficial, but they can be very dangerous if not appropriately managed. And so what we have to be really careful about is we don't want to create an isolated spot for that temperature. So for that heat, we want to create a large basking area, because what we don't want is an animal to get a burn, because they will get burned because they are trying to effectively heat their entire bodies, which in the sun they would expose their entire bodies. But sometimes in our environments, we're providing small basking areas that provide a very small area that they have to sit in for a very long time to reach their preferred body temperature. And then that can result in a burn, a thermal burn. So that is something to look for. That also can occur if you don't give an animal a gradient. It's cold, and then there's this one hot spot. So they're going to over sit in that spot to try to reach preferred body temperature, and they're going to burn themselves. But then also thinking about overheating just in terms of the ambient temperature. So I have this turtle, just muted myself. Sorry, I just accidentally muted myself. I'm trying to move you guys around so I can see my whole screen while I present. So sorry, it's blocking it a little bit. I think I can shrink this up. There it goes. Okay, so here you can see the difference between the air temperature, the temperature of the tortoise, and then the soil temperature. So that's really important to remember. The temperature of the tortoise and the temperature of the soil are much hotter than the air temperature. Air temperatures at those temperatures would kill these animals. So that's another thing that you need to consider when reading temperatures and providing temperatures to our animals. The next category is vision, and basically what we do for our animals to see appropriately. And this one I think is very complex because it's really hard for us to evaluate how other animals are seeing the world. And there's actually there's a lack of studies on behaviorally the visual spectrum of some animals. So I'll give an example. We know that crocodilians have rods and cones, so they have the ability to see certain colors. But behaviorally, we have no idea if they utilize those or if those are remnants of evolution. And maybe they don't see all colors, or they don't see all spectrums and brightnesses. And so all of these things need to be taken into consideration when we think about our animals. What we do know is that many reptiles do see in UVA, and you can see on here birds, some mammals, but humans do not see in UVA. So that makes it really hard for us to evaluate the lighting we're giving them unless we have some way of reading UVA lighting, right? So that is really important when considering how we keep reptiles. A lot of people keep snakes in drawers, in racks with no lighting, just that underground IRC heat. And so I think it's really important to consider their vision and how that impacts their behavior, their communication with each other, and how they hunt and their prey choice. And so again, we're thinking about the visible light and the ultraviolet light. Visible light does, they both do a lot more than provide good communication channels in terms of the animal's vision. They also do like provide increased nitric oxide and are good and for lowering their blood pressure. UVA is also absorbed by the animal and internally translated into energy. So really important for our animals, these spectrums. And then again, humans can't really see in these spectrums, but a lot of species have UV markings. And a lot of foods have UV markings. And so that's a big part of how these animals are behaving and a big part of their natural history that I think has been completely overlooked and overshadowed over the years. But now herpetoculturists are starting to recognize this and trying to provide better levels of UVA. And so how can we measure UVA? So I like these solar meters. You can get a solar meter that reads the UV spectrum. You can get one that just does UVB, and you can get one that can separate it out UVA to UVB. And then there are these this index that you can utilize that they've made for reptiles specifically, but I think it could be translated easily to other species as well. All right, so sorry, gap in pictures here because I didn't finish this slide. But how do we give UVA to our animals? So the good news is that a lot of light bulbs do have some levels of UVA in them. So a UV bulb, a UVB bulb does have UVA. LED bulbs have great UVA, and there's small amounts of UVA and visual light in a lot of the halogen light bulbs as well. So I think for this specific category of lighting, LED lights are generally the best way to go. But fortunately, if you're giving the right heat bulbs and UVB bulbs, when we measure, we will see that you are giving a fair amount of UVA as well to your animals. And things that we want to move away from are bulbs that do not have UV. So solely using red lights or ceramic heat as basking spots or as heat spots with no other lighting is a bad thing, and you really want to move away from that, because you can see that lizard who we saw the UV markings on in the UV light now has no markings under a red light. So providing solely red light as a basking area is really inadequate for a reptile. And I would probably say all taxa. All right, and the last category is light intensity or activity levels. And so this is really important because this obviously dictates how these animals behave in a day or in a year, which is critical for reptiles, particularly for usually their breeding cycles, especially for temperate species up here, like where we live, where there's a brumation cycle and seasons and daylight is shortened. That's a really big indicator for these animals. It indicates when food is going to be available, when resources are high, when they want to reproduce. And then it also will dictate when females are moving. So males know, you know, this is breeding season, that we'll be able to find females and when to and how to allocate their resources. So what's important here is that the light needs to be bright. It needs to be bright enough to stimulate the brain. And it's going in through two areas on a reptile or on lizards. But basically for every animal, we're thinking about how this penetrates the eye and how then they utilize that to trigger their brain functions in a way to dictate daily activity and seasonal rhythms. So how can we measure that? We can use a lux meter to measure light intensity. So I have a lux meter also, just in case anybody is interested in this. And then basically what we're looking at is how much light is reaching the surface. And that's how we can read the intensity of our bulbs. And then this is really cool. You can see kind of a lighting scheme here where this is what we see on the left, but this is what the reptile sees on the right in terms of the light intensity. And so this is obviously not an ideal habitat lighting scheme for this animal, but from our perspective, it looks really good. It looks really well lit. That Arcadia bulb that they're talking about at the top is a UV transmissible bulb. And then they're using a halogen flood lamp for the basking spot. But you can see in terms of light intensity, this is not adequate. So how do we give the right intensity to our animals? Multiple light fixtures and multiple types of lights. So this is the trick, is that there's just not one bulb or one thing that can fix all. And so when I was a keeper, we thought that these mercury vapor bulbs were like the ultimate lighting, right? They were heat, they were UV, they were bright. We thought that was the way to go. Of course, in no way was I considering full spectrum lighting. I was considering UV light and what I thought was bright light, visual light, and heat, of course. And so what we really want to do is look at multiple light fixtures, and I'm going to go through those in a minute, but including LED lights and halogen basking spots. Okay, so then the last category we want to talk about, which I think everyone has probably been well versed on at this point, because UVB has been focused on a lot in the reptile field, and I think with birds and mammals as well. UVB is critical. It's critical for vitamin D synthesis, which helps them absorb calcium. So it's also got plenty of other benefits that include being strongly antibacterial. So we also know that UV light can be a sterilizer, right? We leave things out in the sun, or we can use UV sterilization before we drink water when we're in the field. The immune system, beta endorphin synthesis. So like that feel good feeling, you know, this is all really important impacts of UVB, but I would say the biggest focused on is vitamin D synthesis, because we've seen so many problems directly related to vitamin D and calcium absorption. So here's just a little diagram of what happens when animals have optimal vitamin D3, which they get from the sun. So if they get just enough vitamin D3, it's going to help. It's going to help. Any level is beneficial to the animal and is going to help with their bone density and their calcium metabolism. But when they have excess, it will then circulate through their body, and it can affect almost every part of their system. So this is what's really important to remember, is that they can't have like too much. You know, they can get too much UV light, and that could impact their eyes, right? Just like it could impact our eyes. So there is a level of UV we want to provide, but excess vitamin D becomes circulated through their blood system, and it affects all of their functions, including their endocrine systems, muscle function, growth, and reproduction. So this is a critical aspect to our animal care that, again, I think is really hard for us to evaluate, especially in real time, especially with slow-lived animals, that we won't necessarily see the impacts of inappropriate or improper vitamin D levels until it is too late. And so what does that look like when we have a deficiency? It looks like reproductive failure. So either not producing eggs, or the eggs are not quality and they don't develop. We see females pulling calcium from their bones in order to produce eggs, and that causes things like metabolic bone disease. Metabolic bone disease has been seen in a lot of different taxa. It's a big problem. Used to be a big problem in herp husbandry. It's not so much anymore now that we've identified the need for better UV light. And then different functions are affected. Their resistance to infection, their ability to destroy cancerous cells. So vitamin B and vitamin D, sorry, I keep saying vitamin B, UVB light and vitamin D3 are critical. So how can we measure UVB light? So these same kind of meters, the solar meter is basically the one that I've seen used the most and published on the most. And again, you can read this in UVB specific index, or you can do the UV index, or you can look at UVA and UVB combined. So I really like these meters. You can get them calibrated annually, and they are not too expensive. I mean, I would say they're like, I think $150, maybe $200 for the top model. But I think in terms of being able to evaluate what we want to give our animals, this is one of the best sources. And then how do we get UVB to our animals? There are lots of bulbs out there that are touting about their UV output and UVA or UVB. For me, I'm really a big fan of these Arcadia light bulbs. They've been tested a lot. And they put out a really great range of UV for our animals. Also, UVB emitting metal halides like Power Sun and Sunray are also good. It's important to remember they're going to have a more focused area. So what we want to do is create a gradient with all of these components of sunlight. And then a big area. We want the whole body of the animal to be able to be covered into this natural light scheme that we're going to create. And so that's the one thing about the metal halides, is because they also provide heat. They tend to have a very focused and smaller area. Whereas these Arcadia bulbs, they're tubes, they're T5 tubes. They cover a much broader area with a great output. The downside to some of these are these metal halides only last 3 to 6 months. And they, again, like I said, have a narrow beam. These Arcadia light bulbs are actually lasting a lot longer than these metal halides, but again, they need to be mixed in with other types of bulbs to get that the other spectrums, of course. So here I wanted to specifically call out mercury vapor lamps, because this is what I was told was like the gold standard when I was a zookeeper. And these things really don't do a great job when compared to other lights like the metal halides and the Arcadia. They have small UVB zones. They have poor visual spectrum. They're very variable. They blow out really easily. And you can't really control the amount of IR or heat that's coming from them. So while these tout to be full spectrum and have all 3 of the components, when being tested, they did not test well, is what I will say. So of course, now we take all this information and we want to know the best way to provide it to our taxa. Some of us take care of 1 to 5 species. Some of us take care of 5 to 50 species. And so we need to know our animals, and we need to know their microhabitats, their behavior, and their seasonality to ensure that we're providing the proper spectrums at the proper times of year. So lucky for us, this guy Ferguson came up with these UV zones, basically. So he based these off of microhabitat behavior and behavior. So there's a crepuscular or shade dweller. So any species that's within that you would consider to be crepuscular, or it's an animal that you don't find just out basking in the direct sunlight. And it gives you the range, the UVI range, and then basically the max UVI that's been recorded for certain species that they would consider in that category. And so this is a really helpful chart to go through and say, okay, I want to give my box turtle, my Asian box turtle, they're in the forested floors of Asia in high altitudes. So I would put them in a zone 1 or 2. So basically I'm going to look at 1 and 2. I'm going to look at their basking behavior. I'm going to look at their thermal regulatory behavior. And I'm going to decide, okay, I kind of want them in the lower level of 2 personally. So that's what I'm going to aim for. And then I want to give them that range. You don't want to just blast these animals with heat or UV. We want to give them a gradient so they can select the level of UV or the level of heat that they are needing based on their status. If they're sick, they might want to be hotter. If there's a lack of calcium in their diet, they might need a little bit higher UV light. So remember, these things don't happen in a vacuum. If it's really dry and there's a humidity problem, they might want to move out of the heat and create a burrow and dig down deep where they can get to some humidity and protect themselves from water loss. So it's going to be highly dependent on each species and their behavior, but these Ferguson zones are extremely helpful for a starting point for the diversity of taxa that we do keep in zoos. And then building off that, the AAZK did this UV tool project where they really expanded. So Ferguson based his zones on wild animals and wild natural UV readings. And then the UV tool project really expanded this for a lot of the species that we keep, reptiles and amphibians, sorry, to the rest of the taxa. This one is reptiles, amphibian specific, but really expanded this idea to a whole slew of taxa to make it a lot easier on zoos to kind of try to maintain and create standardized environments for our animals, aligning with what would be considered natural full spectrum lighting for that species. And yes, I think I want to make sure it's clear that there is a such thing as too much, and too much UV light can damage our animals. It can burn them. It can affect their eyes and their vision. So it is important to not just say, oh, my animal needs UV light, I'm going to get the highest wattage bulb and just blast this animal with UV. The minute we want to make sure they have refuge from UV light, just like they want refuge from their thermal ranges. So always giving a gradient, always giving an option to move out of that light, so the animal can behaviorally regulate their exposure. And then again, I want to repeat that this is not in a vacuum, right? So our temperature and lighting scheme is very critically and intimately connected to the humidity that we provide our reptiles and amphibians, as well as our diets. So all of these things are interconnected and important to be taken into consideration when designing a habitat and a husbandry guidelines for your species. So here's just some baseline reminders about when we're developing a heating scheme. So basically we want the basking zones and there to be gradients. So we don't want a basking spot anymore. We want a large area. So look at this tortoise habitat. This habitat has 1, 2, 3 different types of lights, heat operations going on here. They have the patio heaters, they have the LED lights, and they have the UV lights in those big panels on the roof. And basically they've created a large area that has a gradient of temperatures as well as UV. And it's important to remember the animals don't separate out the portions of sunlight, right? They get them all at once. So they're not able to say, oh, I just want UV or I just want heat, right? They all come together in a package from the sun, but they come in a gradient that the animal can select from. Make sure we're measuring surface temperatures, not air temperatures. And when we're thinking about our animals and how they are basking and absorbing heat, we want IRA, UV, and visible light from above. And then we do and can offer IRC from the side or below. And again, we are going to need multiple fixtures. And so I think the ideal scheme that I think works the best at this point, although I need to do some more tests myself, are patio heaters, these UV T5 high output bulbs, which seem to last a little bit longer and put out a great UV gradient, and then these metal halides to make sure we're giving our animals everything they need. And then just a side note that these mesh guards, people are very, very afraid of reptiles burning themselves. In my experience, if an animal is given the proper gradient in the proper way, it will not go and lay on a light bulb. I think people are also very worried about bulbs breaking into habitats. But I would say that these guards, they do seem to block out the light and UV. And so they go against kind of what we're working towards in terms of these lighting schemes. And so they should be avoided when possible. All right, and just to wrap it up again, we want short wavelength heat, we want visual light, and we want UV light to provide full spectrum lighting. And this creates a multitude of benefits for our animals and for our animal health.
Lauren, that was awesome.
I wonder how I get you back full. Here you are. There you go. That
was awesome. That was so interesting and can definitely probably translate to birds for me.
For sure.
If anyone has any questions, feel free to unmute to ask. We did have a question in the chat that Andrew was awesome enough to answer, but I want to capture it on recording. Someone was just asking what a UV marking was. I don't know if so Andrew said flowers, fruits, and animals have coloration displays that different animals can see. An example was pollinator insects see flowers in a different UV spectrum than us, and this attracts them, or a lizard has certain markings that other lizards can see to communicate.
Yes, nailed it. Great job, Andrew. All
points for me.
Yay.
I might have to unmute everybody.
Yeah, it looks okay. I can unmute you. If you guys raise your hand, I can try and go through. I'm not very good at technology, but yeah. It won't let me.
I can unmute myself.
Oh, there you go. Thank you.
Another Zoom trick I'm told is that if people raise their hand, it's up. It follows up across the top whose turn it is.
I saw.
Yeah.
Oh, okay, perfect.
I learned that kind of late in the whole Zoom game, but I want to say that I think this was so interesting, and I think you were successful in breaking it down to layman's language and terms. I have a couple of questions. One is all of this science now and all of these discoveries part of the AAZK auditing process when they go around to zoos to make sure that these animals are being cared for properly?
That is a phenomenal question. And no, it is not. UV lighting is on the AZA. You mean AZA, right? The AZA.
That's what I mean.
Yes,
Yeah,
okay.
I always get those acronyms mixed up.
Yes, I would say that AZA is definitely looking more at UV lighting, particularly in reptiles and amphibians. I think the biggest problem is because I still will tell you, this is so complex. And it is even hard for me to keep it straight sometimes when I'm trying to explain it to others. And there are scientists that are not reptile people that are working on Frances Baines, she's not a herpetologist, but she is very interested in UV light, and she has taken the perspective of a herpetologist in doing so and become like the #1 person that herpetologists go to. And she's highly involved now in the Advancing Herpetological Husbandry group. But I think the reality is, do they look and see if we're offering it? They do ask now. Do they require it at this point? No. So I was part of St. Louis Zoo's inspection. At St. Louis Zoo, we did not offer UV lighting to all our animals. They did not ask me about UV light. They did ask me about the UV light being offered to the children's zoo animals at St. Louis. And so it was an interesting thing, but I think it is highly dependent upon your inspector. And infrequently do you have a reptile person as an inspector. So I think because the knowledge is not completely out there or completely accepted by the community. So there are reptile people and herpetoculturists that don't think that snakes, I'll just say, that don't think snakes need UV light. There is absolutely no evidence right now that snakes need UV light. I think that snakes need UV light. They are exposed to it in the wild. And I think that they definitely utilize it in their vision. But a lot of people keep snakes in a rack system with no direct lighting and just IRC, like I was telling you, underground heat. Now, the theory here is that crocodilians and snakes, they eat their prey whole. And so they don't need that extra calcium metabolism that the vitamin D is providing from the UVB light. But I think that's a very singular focus. They're not thinking about full spectrum lighting and all the other benefits that are given to our animals. There's also I'm going to go into too much detail for you, I'm sure, but there's also the idea here that we're not capable of providing these kind of resources to our herp collections while still maintaining sustainable, large populations. And so it's a balance that we have to be very careful with. So do we want to have conservation breeding colonies and sustainable populations of hundreds of species that may or may not need UV light, or would rather say, you know what, they're living 25 years, they're reproducing to a level that I, as their keeper, think is fine, so I'm not going to even investigate UV light? Or do we want to say, we want to improve these animals' lives because they could live longer, they could have improved reproductive output? It's really honestly, I think, kind of a hot, untouched topic in herpetology that I like to talk about because I think we can do better. I think we can do a lot better without negatively impacting the collection size or the sustainability of our programs. But it has to be, we have to drive this with data. So I was doing some studies in St. Louis looking at snakes, snake welfare specifically, because snakes will live in a drawer forever. And maybe that's great, but maybe they're fine. Maybe they like it, maybe that is good welfare. But we have to be, as zoos, ready to defend that or change it. And we can't do that without the data. So we were looking at snakes, starting with actually what Roger Conan, oh man, whoever saw my talk the other day is going to hear a repeat now, but Roger Conan at the Philadelphia Zoo was one of the first people to document that when you keep snakes on newspaper, which historically we did, right? We kept them in a tank or a drawer on newspaper with a water bowl and maybe a hide box. When you change that newspaper, you arouse the snake. So the first thing we need to do is figure out, what is a snake look like that has poor welfare? And what does a snake that has good welfare look like? What are those indicators? Because I can ask probably 50 herpetologists to write down 2 welfare indicators for snakes, and I bet they would be very different. So first we have to get on the same page with what is good welfare look like from our perspective, because we're evaluating it. And then Then we can look at how to use those welfare indicators to evaluate husbandry. Do they need perching? Do they need UV light? Do they need multiple basking spots? Do they, do they metabolize better when they have overhead IR as opposed to under the mat solely IR? So anyway, I digress. Started doing these studies at St. Louis to look at that. And I really want to do a study on the long-term impacts of full spectrum lighting on snakes versus just that underground, that underground heat that is typical of snake housing. And Andrew is a herper on here. So Andrew, I would love, if you want to chop in, I think a little good discussion never hurts anything. So that my answer, so sorry, long story short with AZA is it's on the radar, but I think until, and I believe the herp community should be driving our standards, but until we get up to par, start collecting that data and start making those recommendations, it's hard for AZA to know, where to fall on that line.
I'm surprised to hear that there's not animal taxa specialists who are doing these evaluations or audits. Like you said, there's not usually a reptile and amphibian person on the team doing the evaluations. So that kind of was new news for me.
The teams are like 4 or 5 people, and usually there's a veterinarian on the teams, I think. So St. Louis was my second go through an inspection, but my first time as a curator. So my first time like really being questioned and being asked about it. And Andrew, how do you feel about herp standards?
We got some back and forth going on here. I mean, I agree with what you're saying. There's a lot of information we just don't know, and a lot of people go based off of what's been done and what they've been doing. I also personally am not a fan of snake drawers. There are occasions where, like in emergency situations, like something's going wrong, you might have to put them in a drawer for a day or two. I don't think that's bad, but long term, we don't know what the negative effects are. I could stick someone in a room with no light or anything, they're still going to live, but they might go crazy. But we just don't know how the animals are, mentally. They can't tell us that something's wrong, as well as other certain animals can. They're not going to sometimes show as much behaviorally, and there are, just reptiles in general. There are people out there who are trying to improve, and I myself am one who has animals at home. I'm upgrading my animals at home and upgrading my lighting while I learn new things. And a big part is it can be expensive. So especially when you're mentioning the number of animals, it adds up. Lights go out, and those lights are not very cheap. When you actually start buying multiple lights and multiple fixtures, it can add up. So I think it also comes down to how much people are willing to spend on their animals. And if they're living and reproducing, they're not going to spend that money, which is unfortunate.
Yeah, what I found is it's hard to make an argument to change things when reptiles in general are slow living, and because of their metabolisms and the length of time it takes, there's not a direct link. Usually when a reptile dies, you can't say, oh, this is because you didn't give it UV light. Like it's not that simple. There's so many factors that play into it. So the problem that I see with our field right now is the lack of data collection. People are making these changes. So people are upgrading their lighting based on science, which is great, but people are not documenting the before and after. And we don't have enough long-term studies to show that these things are actually really showing impacts in our collections. People just see the science and make the changes. And so one of the things I'm trying to push in our community is collecting that data. If you're going to make a change, just try to collect some pre and post data, because it will take centuries before we actually see the results of our changes in our management as a whole, as a community.
On that note, or if anyone like myself who has reptiles, what changes would you want people to look for? Like if people see this at home, share it with people. What changes, if you're switching over your lighting, would you be looking for?
So what I would do is I would take readings of my old lighting. So I would get a lux meter, a temp gun, a solar reader. I would say, okay, this is what I was offering them. This is what was available to them. Okay, this temperature range, this lighting scheme, this UVA, this UV spectrum, whatever. I would get that data. Then when I change my lighting, I would get the new scheme. So here's what I changed to. And then so you will be able to see what did you really change? Because likely you're not going to change your thermal gradient. I'm sure your thermal gradient is ACEs, right? You're probably looking at UV and visual light. Am I right, Andrew? And improving that?
Yeah.
So that's good because then you can isolate the behavioral differences or the reproductive differences to UV lighting and visual light. And then you can start to evaluate behavior. I mean, unless you're doing behavioral studies where you can like categorize behavior, you're just going to be looking at their natural behaviors in your habitats, because it's not like you're doing anything that, like, I was doing studies with crocodiles where they would select something based on the color, based on the brightness. So I was able to evaluate changes based on how they responded in that study, if that makes sense. So it's a little bit more complicated when you're just talking about changing the lighting on a few animals. But if you do see positive changes in your collection, it's important to say, okay, these changes followed this new lighting scheme. And it's small potatoes, if you know what I mean, but it's worth, I think, every little observation, I think, is worth it right now since we have nothing. Sorry, I rambled on that question for a long time and I realized we only have 15 minutes. So
Phil
I
has a
think Phil-
question.
Yeah, I think Phil has a question. Oh, Phil, you have to unmute yourself. I can't.
You're still muted, Phil.
At work.
yeah.
Anyway, being a reptile person from the time I was, 5 and 6, I had a friend that, well, he was a guy who lived with some family. They would take in people, and he was an older guy. He was maybe in his teens, and I was like 6 or 7. And I remember his name, but I also remember that we would go out and look for snakes, and he would tell me, well, don't reach under that rock and stuff like that. But I carried most of that until I graduated from college, because I had a couple things, but I didn't keep anything at college. But once I started teaching in 1970, I started accumulating reptiles in my classroom, which was, a benefit, not just for me, but also I think for the students, because it gave something interesting for them to come every day when they had biology, and there was something different going on often all the time. But as far as lighting, I wasn't a whole lot concerned about lighting, other than the facts providing them with safe heat. Because when say, well, you need a light bulb, people say, well, you just put a light bulb. Well, if you're not measuring the distance between just a regular incandescent bulb and the top of the animals, talking about them roasting parts of their body, that's something really critical. But knowing that, for years, the idea of different types of lighting. I have a African sulcata. His name's Peabody, but I've had him for 27 years, and he was ping pong ball size when I got him, and he's like this, if that makes any sense, but he's about 85 pounds. And anyway, when he was young, I would always, in the summer, I would keep him outside, and with access to shade, but that I would keep them outside in the warmer months. In the cooler months, he would be inside, and he would be heated, but not with anything UVB. It wasn't until I'd say maybe close to 20 years that I read stuff about UVB, and I started providing him, and would take him in. He was usually out from June till like mid-September, because where we live, it's not really safe for that type of an animal to be out any much longer than that. And I had a heat lamp. I had a heat lamp on for evening up until about the last week in September. And I was concerned because there was one spot on one section of the shell that looked like there had been excess heating. So I've always been taking him in. The last couple of years, he hasn't been inside, hasn't been outside, mainly because his weight is becoming a problem for me. And as far as taking him in and out, it's not the same thing as, when they're this big to when they're this big. And so I provide UVB. And again, the thing about, I pulled out one of these bulbs when I knew we were talking about that, but it's so confusing for a lot of people. And I taught science and, trying to digest the information in terms of the wavelengths, also the distance from the animal, how the bulbs have to be set. And for animals that are kept individually, like people that, there's lots of people that keep reptiles for pets, but it's kind of minimal because, the amount of space that you have to deal with is less than what you would have in a zoo situation. And obviously, in the zoo, you have a lot more space to cover, and that's certainly an expense. I bred snakes, and I understand the idea that, in breeding, light is important, and have discovered, that at least all the data seems to suggest, as other people would say, that they don't seem to need it, but we're not entirely sure. Snakes aren't the type of animals that, wag their tails and say, this is great, let's do more of this. But the understanding for the pet trade, at least, the animals that are in the pet trade are getting better care than they used to. The little green turtles, the different sliders and so on. The reason they only lived a few months to a year is, they weren't providing what was really needed. And today it's a lot better. But at the same time, it's an issue, and I believe it's important, especially for zoos when they're trying to have breeding going on with the two Galapagos females. I heard a word went out that they weren't really looking forward to having any eggs laid, and I wouldn't be that quick to say, let's not give up on that. But our light areas and the temperatures, we can only have them outside, in the warmer months. And exactly, I wouldn't turn off the thought that either of these females that supposedly mated successfully are going to produce eggs, and that one of the last frames that you had there with the zoo enclosure of the tortoises, the underlying heat, that particular heat, I'm assuming that Philadelphia has that in the flooring, regardless, whether it's concrete or with the dirt area where they have a possibility where they can dig. And so I wouldn't really even give it up on them yet. The light, in a breeding season for tortoises that live in the tropics, is going to be affected by the lighting that they encounter during the year in a zoo. So I'm not sure exactly how we're managing that. I don't really have a lot of contact with the keepers that often, at least.
I know.
Yeah.
No, we're actually in the process of renovating our indoor tortoise habitat. We just redid their nesting area, and we're adding big, expansive UV light fixtures.
Okay.
So that they can have UV.
Thank you. This is the first I've really met you, but the understanding is that that I've been looking in there every week to see what's going on. And there was one picture that they said well, the one was over, and I'm assuming that would be one, and it was in position that looked like she was trying to dig a little bit with her back legs. So I don't know. I'm still kind of optimistic.
Oh, I'm optimistic too. I think even if it takes a year, I think we're gonna get there.
Yeah.
So we're really excited.
Be excited.
Can I just say something about the snake lighting too, real quick?
Yeah.
You mentioned about snakes in drawers, not necessarily, we don't know, and I mentioned it, we don't know how they're reacting, but Toronto has done lighting breeding with Eastern Massasauga rattlesnakes, which are endangered. They've done specifically just, instead of doing a hibernation, which can be dangerous for them, If something happens during the brumation hibernation phase that they either dehydrate or something goes on, they've actually done like a study and a thing about where they just reproduce them with the light cycle now. They don't put them in hibernation. So they did that for a little bit just for safety purposes. So snakes can breed, but we also know that the light cycle can affect, breeding and their cycles. And
Perfect.
everything. So
Yeah,
we can,
I was gonna say a lot of the studies.
It's going to be better for them overall, in my, from what we've seen and what we know, and those type of research and studies and testing that. No one's really doing a lot of tests on that. So when we have those things come up, we can prove like, hey, you don't have to necessarily put your animal in this dangerous situation and have no light or anything like that, when we can just change their light cycle.
Yeah, I would say though, is in terms of lighting, most of the studies that have mixed reviews are solely focused on vitamin D levels. So they don't look at the other benefits of vitamin B, of UVB. They don't look at the benefits of UVA. They solely looked at vitamin D because that has been the really impactful thing for turtles and lizards. And so while there's mixed results on that, depending on the taxa, again, that's just one small thing that UV light does. That's not the full picture. Awesome. I see Karen has a question about diet that I'll just really quickly brush over that. Yes, we do supplement reptiles with different supplements. So usually it's a high calcium type of powder that we put in their food, dust their crickets with, put on their salad. But there's a multitude of reptile vitamins that are available and that you can use to help with a multitude of health issues. So like a lot of amphibians get what's called short tongue. So they need vitamin A a little bit more. So, but yes, there are supplementations, and nutrition is just like a whole nother bag of worms that is like super excited to think about, because one of the things you want to remember about nutrition is you want to figure out what they're eating in the wild, but not just what they're eating, the nutritional composition of that diet, because we can't give them the exact same thing they ate in the wild. We can give them maybe the same prey, but that prey is also captive reared, right? So the prey is basically not nutritionally comparable all the time. So we want to look at those nutritional factors and implement that into their diet, and a huge lack of data on that in wild reptiles and amphibians.
Thank you. Your explanations are great. Thanks.
Thank you so much, Lauren. That was amazing. It is
Yes.
3:15, so we should probably end here. But if anyone does have any questions, feel free to email me, or I'm going to say Lauren. Sorry, Lauren.
No, go for it.
But yeah, thank you so much, everyone, for coming, and keep an eye on your email because we're hoping to do more of these. And I don't know what topic will be next. I'm fingers crossed for nutrition. So keep an eye on your email. But thank you so much, everyone, for coming. And thank you, Lauren. That was amazing.
Thank you.
Yeah, no,
Thanks.
thank you guys.
Yeah, very
Bye.
good.
Have a good weekend,
Bye-bye.
everyone.
Have a good one.